Good day everybody. The topic of this tutorial video is percentage change and percentage errors, and it's a continuation of the previous video on percentages. I am Lamide. So the lesson outcomes. After watching this video, you should be able to understand how to calculate the percentage errors and percentage change. And the lesson objectives are to understand exact value and approximate value, also to understand how to calculate change and error, and to understand how to calculate percentage error and percentage change, and lastly to understand how to solve problems involving percentage change and percentage error. So percentage change. Percentage change can either be an increase or a decrease, and it's used when comparing an old value, which is called an initial value, to a new value, which is called the current value. So the initial value of a parameter is the original value, the value of the parameter before the increase, the increment, or a decrease, while the new value is the value arrived at after increasing or decreasing the value. So to estimate percentage change, the procedures are: first, you estimate the change. So change equals to current value minus the initial value. So the difference between the current value and the initial value is will give you the change. So now, after calculating the change, then you now calculate the percentage change using the expression percentage change equals to change divided by the absolute value of the initial value times 100%. So the absolute value here indicates that the denominator here will be positive, regardless of whether the sign of the initial value is positive or negative. So when dealing with percentage change, you have to know that the word change may be replaced by an increase, decrease, profit, or loss. So all basically mean the same thing but in different contexts. For instance, the profit or loss is used to denote percentage change when dealing with monetary values or businesses, while increase or decrease applies when dealing with they are general terms, increase and decrease, but profit and loss are specific to business and monetary values. So a positive value of percentage change is an increase, while a negative value is a decrease. So whenever you arrive at a negative value of percentage change, what you do is just to remove the minus sign and call it a decrease. So in essence, you might have a situation whereby the change here will be negative. So as a result, the percentage change will be negative, which shows that it's a decrease, it's a percentage decrease. So to now put your answer, you simply remove the minus sign and you signify that it's a decrease once you have a negative value of a percentage change. So let's look at percentage errors. So the definition of important terms. Percentage error shows the error as a percent of the exact value. So the term percentage error is used when an approximate value is compared with an exact value. So the approximate and exact values, these are the two major categories of numbers used in technical applications. So in technical applications, the two major categories of numbers used are the approximate value and the exact value. So what are approximate values and exact values? So approximate value are values which are the results of the measurement relative to a continuous scale. And examples of this type are lengths, masses, times, etc. So when you are the values which are results of measurement relative to continuous scale, such as length, when measuring length with meter rule, masses with weighing balance or analytical balance, and times with stopwatch. These are continuous scales. So any value you arrive at as a result of measurement using these scales, they are referred to as approximate values. So for example, a table is 150 centimeter tall, probably mean rounding to the closest whole centimeter, its height is 150 centimeter. So whenever you see a measurement taken relative to a continuous scale, such as 150 centimeter, which is a length, the value for the height of the table in centimeter. So with this, it's an approximated value, not the exact height of the table. And the reasons for this are the first is with a much more precise instrument or apparatus, you might be able to determine the height of the table to be 150.33 centimeters. From the previous video on significant figures, when you approximate 150.33 centimeter to the nearest whole number, or let's say to three significant figures. So having 150.33 centimeter, for instance, that's 150 centimeter, shows that the measurement here has been taken with a much more precise instrument than this. So another reason is that the number of digits used to state the table's height in centimeters depends on how precise the technique of measurement is. This has been explained in the previous point. So the more the number of digits after the decimal point, the more precise the measurement is. So another reason is no matter how careful we are, we can never say that we have measured the table's height exactly to all decimal places. Yes, of course, because when working with continuous physical quantities, it is not possible, practically impossible to get the exact to measure the exact value of the table's height. So the equipment will only be able to measure the height to up to the extent of its preciseness, how precise the equipment is, not measuring the exact value. So the last reason is instruments exist which enable measurements of lengths to within less than a millionth of centimeter. So as you can see here, there are instruments which could measure length up to a millionth of a centimeter. So this shows that the more sophisticated your equipment is, the more precise, which means the more closer to the exact value your measurement will be. So that is all about approximate value. So now let's have a look at exact values. So exact numbers do not have the kind of uncertainties which are stated in the approximate values of a parameter. So all the uncertainties involved in determining the value of approximate numbers as a result of the precision of the instrument involved. This doesn't apply when dealing with exact numbers, and their value are always exact, and there is always no error involved in determining their value, because they are not approximate, but rather they are exact values. So these exact values basically occur in two different cases. So the first case is the result of counting discrete items. So for instance, the number of 1 dozen of egg. So when you have 12 eggs, it's always a dozen. So there is nothing like 12.1 eggs, 11.9 eggs, or any other decimal number appearing as the number of eggs in a dozen. It's not possible. The number of eggs in a dozen is 12, and it's always exact, no more, no less. Another example is the number of cows in a herd. It can also not have a decimal part. It will always be an exact number. It's either you have some number of cow or you have no cow. So there is nothing like 0.5 cows in the herd. 0.5 people in the hall, 2.3 people in the hall. All these things are not possible because they do not occur when dealing with exact values. So the number of cows in the head, the number of people in the hall, it's an exact value. So also the number of computers on the network, the number of bytes on the memory of the bytes of memory in the computer. All these stated examples and many others are always exact by definition. So they are all precise whole numbers and they're never arrived at by rounding up. So saying rounding to the nearest whole chicken, I have 50 chickens in my poultry is a wrong statement because the number of chickens in the poultry is an exact value and it's not arrived by approximating or rounding to the nearest whole number. So it is always exact by definition. So the second case, so important fundamental numerical values may be exact by convention, international agreement, or basic definition. So by convention, which is usually a meeting of professionals concerned regarding the use of a particular unit of measurement, or international agreement, which will be reached by different countries regarding a particular unit of measurement, or the basic definition given to those particular units of measurement. So all these sort of exact numbers are most common when we look at units of measurement. So the examples will make the explanation clear. So by international agreement, they are exactly 2.54 centimeters and 1 inch. So for instance, 2.54 centimeters has been taken to be 1 inch. So 2.54 in this case is a decimal number, but it is not the rounding off of a lengthier decimal number. So unlike when dealing with approximate values, whereby when the number of the decimal places after the decimal point depends on how precise the equipment for the measurement is. Here the 2.54 is not arrived at by rounding up of a lengthier number, but rather it is by convention, by international agreement, 2.54 centimeters. So exactly, so it's exact value, so it's not approximate. So 1 inch equals to 2.54 centimeters is an exact value by international agreement. Also, the relationships between SI units of a particular family also involve exact numbers, such as the number of centimeters in a meter, which is 100. 100 is not has not been arrived at by approximating, but rather it's an exact value, and therefore 100 centimeter exactly make a meter. So and this is the international agreement, which is the SI System International Units. So by international agreement, 100 centimeters makes a meter. Also in geometry, a square has exactly 4 sides because that is the characteristic shape to which the word square refers to. So a square has been defined to be a shape that has 4 sides. So and that is the characteristic of the shape square. So it's not approximately 4 sides, but it's exactly 4 sides. So any shape with exactly 4 sides is a square. So now let's move on to the main heading, which is calculation of percentage errors. So having discussed what approximate values and exact values are in details, so now the next thing is to explain how to calculate percentage errors. So the procedures involved in calculating percentage errors are: first, subtract one value from the other to get the error. So the error is the difference between the approximate value and the exact value. And then divide the absolute value of the error by the absolute of the exact value. So the absolute value of the error is the positive value of the result of the difference between approximate value and the exact value. And as explained under percentage change, the absolute value of the error implies that the error will be taken as positive, irrespective of whether it's a positive or a negative value. So after dividing the absolute value of the error by the absolute of the exact value, so the result is then multiplied by 100%, and then you arrive at the percentage error. So thus, the percentage error is calculated using the formula percentage error as explained equals to approximate value minus exact value all over the absolute value of the exact value. So the absolute value of the error here divided by the absolute value of the exact value times 100%. So this by the time you substitute the values here, you arrive at your and simplify further, you arrive at the percentage error. So note, you have to note this. The absolute value sign is to eliminate the minus sign which may appear in the result. So this has been explained, and you only ignore the absolute sign if you are interested in knowing whether the error is under or over the exact value. So in essence, in order for you to be able to know whether your error is much more, whether the approximate value is more than the exact value or less than the exact value, so you may ignore the absolute sign. So by so doing, in the numerator here, when you ignore the absolute sign, if the approximate value is greater than the exact value, so that means it's a percentage, so the error is an increment. So as a result, the value here will be positive, and so the percentage error will have a positive value. And on the other hand, if the exact value is greater than the approximate value, which means the error, the value you arrive at here will be a negative value, and the percentage error will have a negative value, which is a reduction. So the result of approximation in that case must have led to a reduction in the value of the exact value of the parameter you are considering. So that is the essence of the absolute sign. So it depends. Under examination condition, it may not be necessary to ignore the absolute sign. However, it's always advisable to have a glance at your answer, since JAMB examination is an objective exam. So you have alternatives as options. So you could just quickly go through the answers and see the format. If the format doesn't have the sign, the percentage errors are just stated without positive or negative sign, that means you leave the absolute value here. But if you observe that there are positive or negative signs in your options, then you have to ignore the absolute signs. So that's how to make use of the absolute sign in solving problems related to percentage errors. So now, having explained the concepts of the percentage change and percentage errors, so now let's have a look at some sample questions to clarify further the explained concepts. So sample question 1, this question is from UME 2008. The cost of kerosene per liter increases from 60 naira to 85 naira. What is the percentage rate of increase? So the ScoreBooster solution. Now, percentage increase, the formula used in calculating percentage increase is change divided by the absolute value of the initial value times 100%. So now the change equals to current value minus initial value. So now from the question, the cost of kerosene per litre increases from 60 naira, which is the initial value, to 85 naira, which is the final value. So the initial value is 60 naira and the current value or final value is 85 naira. So the change is the difference between the initial value and the current value. So 60 minus 85 naira gives 25 naira. So now the percentage increase is the change divided by the initial value times 100%. So when you divide both the numerator and denominator here by 5, you have here 25 divided by 5 gives 5, and 60 divided by 5 gives 12. So 5 over 12 times 100% equals to 41.67%, which is approximately 42%. So another sample question. The question is from UTME 2010. The student measures a piece of rope and found that it was 1.26 meters long. If the actual length of the rope was 1.25 meters, what was the percentage error in the measurement? So one of the most important things when dealing with percentage change and percentage error is the identification of the actual value. In the case of percentage error, is the identification of actual value and the approximate value, and for percentage change, identification of the initial and the current value. So those are the major important things when dealing with percentage errors and percentage change. So here now we have to identify or determine our approximate value and exact value. So let's try and look at the question to gain a better understanding. A student measures a piece of rope and found that it was 1.26 meters long. So by measuring with an equipment which has its error associated with it, or which has the level of precision, he arrived at the length of the piece of rope to be 1.26 meters, which means the approximate value of the length is 1.26 meters. If the actual length, and it was even stated here to make the thing easier, so if the actual length of the rope was 1.26 meters, so the actual length has been given to 1.26 meters, and that confirms the fact that 1.26 meters is the approximate value, which is because it was a measurement taken relative to a continuous scale length. So now the error is difference between the approximate length and the actual length. So the actual length is 1.25 meters and the approximate length is 1.26 meters. So the difference is 0.01 meters. So this is the error. So and since the error has a positive value, so applying the absolute value sign is immaterial here since it's already positive. So now since we've determined the error to be 0.01 and the exact value is 1.25 as given in the question, so the percentage error is 0.01 divided by 1.25 times 100%, which is equal to 0.8%. So now these are practice questions, and I'll advise that you should lay your hands on each of the practice questions before going through the ScoreBooster solutions, in order for you to be able to test your confidence and understanding of the topic under discussion. So the solutions to the practice questions. So the first practice questions, the first of the practice questions: after getting a rise of 15%, a man's monthly salary is 345 naira. How much per month did he earn before increase? This question is from UME 1979. So the ScoreBooster solution: let the monthly salary before increment be X. So since we've not been given what the man's monthly salary before the increment is, which is his original salary, that has not been given. But the one which was given was that which he earns after the increment of 15%. So the percentage increase in his salary is 15%, and his original salary is unknown, so we represent it by x. So the formula for calculating the percentage increase, so change in this case means increment. So the percentage increase in salary equals to increase in salary divided by the absolute of the original salary times 100%. So increase in salary now is the new salary minus the initial salary. So substituting the values into the equation here, which will be used in calculating the percentage increase. So the increment is 15%, so it's 15 here, and then this is the change or increment in the salary, which is the new salary after the increment minus the original salary divided by the absolute of the original salary, which is x times 100. So when you cross multiply, you have 15x equals to 345 minus x times 100. So 15x equals to 34,500 minus 100x. So when you add 100x to both sides, you have 100 plus 15x, which is 115x equals to 34,500. So x equals to 34,500 divided by 115, which is equals to 300 naira. So alternatively, using a general understanding of percentages, the concept of percentages, given that the increment in salary is 15%, the month's new earning is 100 plus 15%. And if you could recall from the previous, the first video on percentages, which when a quantity has been increased by a particular percentage, then the quantity will have a value which is more than 100% of its original value. So, and here, for instance, since the value has been increased by 15%, which means the value 100% of the value plus 15% of it is the new salary of the man after the increment. So as a result, 115% of his monthly salary, of his original monthly salary, is what he now earns, and that amounts to 345 naira. So, and since the off sign could be replaced by a multiplication sign, so 115 divided by 100x equals to 345 naira. So when you cross multiply 345 times 100, then you divide both sides by 115. So you have x equals to 345 times 100 divided by 115, which equals to 300. So the old salary of the man before the increment is therefore 300 naira. So as you can see, we've arrived at the same answer. So under examination condition, this alternative method is the best, as it saves considerable length of time, so that you could have some other time to attempt other questions. So another the next practice question: the radius of a circle is given as 5 cm, subject to an error of 0.1 cm. What is the percentage error in the area of the circle? This question is from UME 1992, and the ScoreBooster solution. Approximate value equals to 5 cm. So now, the radius of a circle which has been subjected to an error is an approximate value by definition, which was given earlier. So the approximate value is 5 cm, and now the error has been given to be 0.1 cm. So now we're asked to find the percentage error in the area of the circle. So now, using the relation, the error is approximate value minus exact value. So the error is 0.1 centimeters equals to the approximate radius, which is 5 centimeters, minus the exact radius, which is unknown. So the exact radius will be 5 centimeters minus 0.1 centimeter, which is equal to 4.9 centimeters. So now, the area of a circle is equal to pi r squared, and the actual area is pi times the exact radius squared, and we've calculated the exact radius to be 4.9 centimeter here. So the actual area is pi times the exact radius squared, so which is equal to 24.01 pi. Also, the approximate area is pi times the approximate radius squared, which is pi times 5 squared, which is 25 pi. So the reason why we've not substituted pi to be 22/7 in this case is because there is a denominator in the relation for calculating percentage error, which would make the pi in both the numerator and the denominator to eventually cancel out. So there is no need of substituting pi or 22/7 for pi in this case. So the percentage error in the area is equal to the absolute of the approximate area minus the exact area divided by the absolute of the exact area times 100%. So which is equal to 25 pi minus 24.01 pi. The absolute now divided by 24.01 pi absolute. So when you do this, when you evaluate this, you arrive at 0.99 pi. So and here is 24.01 pi. So the pi will cancel out in both the numerator and the denominator. So when you solve this using your calculator, you arrive at 4.123%, which is approximately equals to 4%. So this question can also be attempted using by applying the concept of calculus. So but here it's not within the scope of this video, so that is why we've not showed how to use calculus to solve this particular problem. But when you use calculus or apply calculus in solving the question, you arrive at the same answer, and the approximate answer to be 4%. So they are all the same or different methods. So the third practice question, which is the last. If the surface area of a sphere is increased by 44%, find the percentage increase in diameter. This question is from UME 1989, and here is the ScoreBooster solution. So before you could attempt a question like this, it's important to know the expression of finding the surface area of a sphere, so which is equal to 4 pi r squared. So now the area of a sphere is increased. So the original surface area is let's represent it with A1, and now remembering the surface area of the sphere is A equals to 4 pi r squared. So the original the surface area, the general expression is A equals to 4 pi r squared, and now the original surface area has been represented with A1. So now, since radius equals to diameter over 2, so the radius is half of the diameter, so A equals to pi d squared. So 4 pi r squared. So the r square here in case of d over 2 is, when you substitute r square with d over 2, so you have d squared all over 4. So the 4 will cancel out, and then you have pi d squared. So that's how we arrive at A equals to pi d squared. So now A1, which is the original area, equals to pi d squared. So so now if the surface area is increased by 44%, so the new area is simply 100% plus 44% of the original area, which means and we've represented the new area by with A2 here. So A2 equals to 144% of A1, which is 144 over 100 times A1, which is, and replacing A1 with its expression, which is pi d squared. So equals to 144 over 100 pi d squared. So now A2 is thus equals to 36 divided by 25. When you divide both the numerator and the denominator by 4, so you arrive at 36 over 25 pi d squared. So and now, since as you can observe, this expression has a square, and these two can also be expressed as expressions having square. So we could group the three together under one bracket. So by grouping them together in a single bracket, so this 36 could be replaced with 6 squared, and also 25 is 5 squared, and so, and d here has a square. So according to the law of indices, so 6 squared over 5 squared times d squared is simply 6 over 5d all squared. So comparing the expression for A2, which equals to which is equals to pi 6 over 5d squared, with the original expression for the surface area of the sphere, which is pi d squared. So when you compare the two, here we have d square, only d square, and here we have 6 over 5d, which takes a square. So which means the diameter, the new diameter of the sphere after the area has been increased by 44% is 6 over 5d. So therefore d2 equals to 6 over 5d. And now the original diameter is d. So here A1 equals to d. So here the original diameter is d. So A1 equals to d. Yeah. As you can see, it's only d that has a square. Like here. We have 6 over 5d carrying a square. So all this together, we consider all the terms under the bracket here, which took the square together. So the d2 equals to 6 over 5d and d1 equals to d. So percentage increase in diameter now is equals to increase in diameter divided by the absolute of the initial diameter times 100%. So we know now that our original diameter is d and the new diameter is 6 over 5d. So the percentage increase in diameter is the new diameter, which is 6 over 5d, minus the original diameter or old diameter, which is d, divided by the old diameter, which is the d, times 100%. So 6 over 5d minus d is simply d over 5 divided by d, so times 100%. So when the d cancel out, we have 1 over 5 times 100%, which is equals to 20%. Thank you for watching this video.